All right, Honors Algebra 2 and Algebra 2. Here we are, Monday morning, 8:30 right now, getting you a very short video here for the 4-1-4-3 game plan. Might have a little bit of noise outside. Some folks this district are getting the COVID test first. All right, so here's the game plan, which will be due before the end of the semester. Definitely this week if you're in Honors Algebra 2, probably next week if you're in Algebra 2. All right, this is the last game plan I will be checking in its entirety. All right, so I made it's probably still due this Wednesday, Honors Algebra 2. And there's an okay chance that next Monday or Tuesday you'll do an open notes quiz. Regular Algebra 2, we'll talk. We might not get to this quiz this semester. All right, so what I did is I just went through, so everyone looking at this packet, Honors Algebra 2, Algebra 2. This is page 2 here. We're not going to do anything here. I have marked down what Algebra 2 and Honors Algebra 2 have done. So let's go page 4 here. Honors Algebra 2 and Algebra 2, this is one. It's in yellow that we're going to save graphing this. Again, regular Algebra 2, you might not have touched this yet. Honors Algebra 2, I know we've gone through this. We are going to wait, and we maybe have done 3. I'm not sure. I've got it in yellow. If not, we'll talk tomorrow in class about what we fully need. So obviously, all of you need to be caught up because there's a good chance this is due on Wednesday. The ones of us that are very squared away, I will be calling on you to see what we need to do. So I don't know if we need to do 3, if we've done that in class or not. That is one, though, I'm not putting in the video. So let's go to page 5 here. Page 5, number 3 and 4 in yellow. We might not have done those. So I expect to do those with you tomorrow, Tuesday, all right? But I will say number 6 here I will do, and I should have done before, but let's do it right here. So what is the vertex of negative 2x squared minus 4x minus 5? So first off, we get that vertex by negative b over 2a. That is the x-coordinate of the vertex. So a is a negative 2, b is a negative 4. So the opposite of a negative 4, that's what negative b means, over 2 times a. That is 4 over a negative 4, which is negative 1. So the x-coordinate of your vertex, so I can go vertex is negative 1 comma something. The x-coordinate of your vertex is a negative 1. The y-coordinate of your vertex is... Look, my handwriting is already not good, so I'm going to try my best. It's negative 2 times 1 plus 4 minus 5. Negative 2, that is a minus 1. Negative 1, negative 3. If I make an arithmetic error, obviously tell me. Got to square that first. Okay, so that's page 5, and that's number 6. The vertex is a negative 1, negative 3. That was one I was planning on doing with you today, and I did, just virtually. All right, so here we are on page 6. We have maybe, again, Honors Algebra 2. This is what I'm talking about. Algebra 2, we'll probably look solely at the matrix packets tomorrow in class. Honors Algebra 2, what I'm saying here is I don't know if we've done this. If not, I will do this one with you on Tuesday. If we've done it, great. Again, this game plan will not be due on Tuesday, but probably for sure for Honors Algebra 2 on Wednesday. Okay, so this is one that maybe I haven't done totally. 3x plus 5 twice minus 13. Again, you can square the first term. Then you take that inner product, which is 3x times 5, and that's 15x, and you double it. That's the trick. Why? Because 3x times 5 happens twice. So we could have gone straight from seeing this binomial squared to my almost answer, and then you square the second term. Again, you can FOIL it out, no big deal. 9x squared plus 30x plus 12. Again, you maybe have that answer, but there it is. All right, so on B, you have the opposite of, again, you can take... you can apply the little trick here. That is going to be square the first term 4x squared. The inner product is a negative 8x, which you would double, and then you square the second term. Don't forget about the negative. That just saves you having to write this twice. If you're in Honors Algebra 2, we will continue to use and get better with that trick. It's really not kind of a trick. It's kind of like a left-hand layup. You just got to know how to do it. Negative 4x squared plus 16x minus 10 is my answer there. All right, so with that, all of page 7 should be done. In Honors Algebra 2, it might already be done. Obviously, Algebra 2, if you're watching this, you don't have that one. Write it down. Let's be wise. Okay, so looking here then, I think this is page 8. Number 2's already been in a video. Number 3, I plan on going over Honors Algebra 2 with you in class Tuesday. I don't believe we've done number 1, so everybody, let's do 1. This is already in Vertex form. Okay, you're going to set that equal to 0. So your vertex is x equals 1. Y is 2. So over here, your vertex, that should be a y, not 1. Vertex is 1, 2. So vertex 1, 2. That means the axis of symmetry is x equals 1. This is a y equals a positive, there's no negative there, x squared. And if you have y equals a positive x squared, it makes the u, and a u always has a minimum. And what's that minimum value? Y equals 2. So you can just fill it out. Knowing the vertex and that it's a positive x squared, you can get all that info there. All right, so the next part's the graph. I go 1 to the left, 1 to the right, 2 to the left, and 2 to the right. Unfortunately, if you plug 0 in, we don't know what the answer is right away. Okay, so I'm going to plug 2 in. I get 2 minus 1 squared plus 2, 1 squared plus 2. Symmetry. Then I'm going to plug 3 in for x. 3 minus 1 is squared plus 2. That is 2 squared plus 2, which is 4 plus 2, 6. 3, 6, negative 1, 6. Remember that symmetry. All right, so negative 1, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2. A boom and a boom. And it makes a U. Man, that's a lovely graph. All right. Again, we've done 2. I got rid of the 0. This one has no zeros. Hey, check this out. This is going to be big. The next game plan, this never crosses the x-axis. It has no zeros, has no x-intercepts, no real solutions. Yet it clearly has a graph. Whoa, that's pretty important. Okay, so that is page 8. Again, number 3 here at the bottom of page 8. Plan on doing with you later. All right, so we skip page 9. So on page 10 here, this is really something we should almost have all the way done. Here's an answer for 1 if you didn't have it, but you can do this on 7. Write it twice, FOIL it out if you need to. Apply the trick. Again, here's the trick. You take that first term and you square it, plus, because the middle, that's positive. Then the inner product is 12x, 4x times 3. Well, you would have 4x times 3, that multiplication occur twice. That's why we take the inner product, which is 4x times 3, 12x, and we double it. Then we square 3. Then we subtract 9. Okay, so that trick, again, that left-hand layup. Which is hard in the 3rd grade, but not for you, varsity stars here. We just need to be able to do, okay? I didn't apply the trick here on 9. I just wrote it out twice. Make sure then it is just written poorly. The negative's on the outside. Multiply everything then by -1 and then simplify it. All right, so let's do 6. State whether it's a min or a max. So first off, this is a negative x squared. Negative x squared makes the igloo, and an igloo has a max. So this thing has a maximum. Let's find it again. It's all about negative b over 2a. b is 6. So the opposite is 6 over 2 times a. Negative 6 over negative 6. I might be called down.
Center attention, high school staff, faculty. If you're not already in line, please
Sweet, awesome. All right, we're gonna keep making this video. Going to, we will not edit that out either. Gonna plug 1 in for X. All right, gonna plug 1 in for X. All right, what are the chances that, I'm really, honestly, at this point, worried about false negatives or false positives. All right, Mr. Jack does not want to have a fault. He's feeling great. If they say I'm positive, I'll be like, give me 2 more tests. Anyway, -3 plus 6 minus 4, -1. All right, so the vertex is 1, -1, and that is a maximum. So 10 and 11 identify the vertex and y-intercept. Well, both of these are written in vertex form. That's why the vertex is 1, 3. Again, set this equal to 0. Because your vertex of your generic y equals x squared parabola has a vertex as 0, 0. What would you plug in for x to make this 0? So that's why we're setting it equal to 0, and we get x is -2. And the y-coordinate is looking at you. It's -8. All right, so the y-intercept is when x is 0, so plug 0 in for x. You're going to square 2, multiply by -1/2, subtract 8. So the y-intercept is y equals -10. Okay, again, that is for everybody, and that's page 10. Pause this when you need to. So, on page 13, this is for everybody here. Let's do this one here. Given the function, find all the following. 1 year I did put this on the test when I was at Mount O, so let's do it. So first off, the y-intercept is when x is 0. If x is 0, 0 minus 0 plus 3, it is y equals 3. So we can clearly see that. Everything else, we're going, like for the x-intercepts, we're going to have to factor. We're going to have to set. Now, we could graph it. We can also factor. I made a mistake. Yeah, I definitely meant that to be a -3. So everybody, catch this. We'll see who watched the video. Catch that. That should be x squared minus 2x plus 3. I definitely wanted a -3. We'll multiply this to 3 and differs by 2. That would be 3 and 1. The middle term is negative, so the bigger factor's got to be negative. You have x minus 3, x plus 1 is 0. Everyone's pretty good at factoring here. X minus 3 is 0, x plus 1 is 0. Cover-up method. X equals 3 and x equals -1 are your 2 solutions, your 2 x-intercepts. So x equals -1 and x equals 3. Well, actually, you have 2 things you can graph there. Let's find this vertex, though, first. So the vertex is -b over 2a. Your middle term is a -2, so the opposite of a -2. All over 2 times a is 1. You get 2 over 2, which is 1. So the x-coordinate of your vertex is 1, and that is the axis symmetry, x equals 1. All right. Now, the y-coordinate of your vertex is the value that you get when you plug 1 in for x. Again, we're making this a -3. I made a typo. The y-coordinate of your vertex is a -4. Plug 1 in for x and that original f of x. So the y-coordinate is a -4. Okay, so what's the range of the function? It's going to be y something in terms of -4. Greater than or equal to or less than or equal to. Well, let's get to graphing here. Well, first off, I know the vertex is 1, 4. X, y. I'm sorry, 1, -4. And 1 to the left, 1 to the right, 2 to the left, to the right. Now, I already know when x is 3, that y is 0, because that's one of my answers. And I know, well, that's one of my solutions. That's one of my x-intercepts. I know when x is a -1, y is also 0. Already found that. So I'm just going to plug 2 in. Oh, no, I'm not. I'm going to plug 0 in. Look at that. I already know that my x-intercept is my y-intercept, which we got to change. Made a boo-boo. Your y-intercept is -3. Now, my y-intercept, when x is 0, I get -3. So then I get -3 there. Now I graph them all. Negative 1, 0. 0, negative 3. 1, negative 4. 2, negative 3. 3, 0. And there's my graph. That had a lot going on. All right, just have that one down, please. And then 3 here, just got to state whether to state the vertex. Okay, so the vertex, all these are in vertex form. You set x plus 3 equal to 0. You get x equals a negative 3. Your y corner of the vertex is staring at you. It's negative 8. This is a negative 7. So makes the igloo. The igloo has a max. Means the vertex is a max. So it's a max. Oh, well, they didn't want that. So what does it do? Does it open up or down? Well, clearly it opens by going down. Well, I gave you everything there. It has a max, there's the vertex, and it opens down. All right, 3A and 3C were in a previous video. So, honestly, everything after that is either in a video or something you need to do. Actually, let's go to page 22 here. Honors Algebra 2, you might have this done. Algebra 2, here's what I mean. On number 8, I'm telling you that we did 7 in class. I'm telling you that x equals 5 and x equals a negative 1/2. So in that parenthesis, if you were to set this equal to 0, doing the cover-up method here backwards, x minus 5 would give you x equals 5. X plus 1/2 would give you that x equals negative 1/2. But we don't have a fraction here in our going back to our quadratic equation here. So we're going to double both terms. Why do we want to double it? We want to get rid of that 2 in the denominator. So double both terms. 2x plus 1, if you set it equal to 0, that's going to also give you x equals negative 1/2. And then first, outer, inner, last. FOIL that for your final answer. 9 is kind of the ultimate one with this question here. If x equals 2/3, x equals negative 1/4. If I were to set this equal to 0, I'd move the 2/3 over, move the negative 1/4 over. I have x minus 2/3, x plus 1/4. I'm going to triple both terms here because of this 3. I'm going to quadruple both terms here because of the 4. So now I have 3x minus 2, and I have 4x plus 1, which I FOILed for you. And then, folks, I believe 23 is either in a video or you got to do it, especially Honors Algebra 2. Page 24 should be good. And then page 26, 27, 28 should also be good. All right, this is Yak Math Video signing out.